Hello and welcome to fourth lecture in seventh chapter of our comprehensive course on AI, ML and DS. We were seeing data wrangling. The name of the chapter is data wrangling with pandas. And currently we are somewhere here. We already saw data wrangling includes the which things. Then data wrangling includes handling missing values, converting data type. These two we have already seen. Outlier detection and duplicate detection and deduplication, identifying single valued columns and removing them, and normalizing and standardizing data. We have already done first and second this. So now outlier detection. Now for outlier detection, yes, important is one is also in previous missing values. This SOM stands for self-organizing map, and ANN is artificial neural network, and MLP is multi-layer perceptron. Multi-layer perceptron is actually the, you can say, precursor of artificial neural network. So before ANN artificial neural network was developed, before that multi-layer perceptron was the building block. A simple one, you can say, one layer neural network, a simple one layer or one element neural network. Now I did not speak the full forms because here they are all research level things. Okay, for example, here I found that this discrete missing data imputation using multi-layer perceptron. So that is advanced and it is research in National Library of Medicine. Similarly, self-organizing map for imputation of missing data in incomplete data matrices. So if I go into that, then I will have to explain what are discrete data and what are incomplete matrices. So these are all research level, PhD level things. KNN alone is enough for that. More important than this diagram. This diagram has only one value, that it shows that mean median mode is not the only way of imputation. There are several more advanced techniques. And second thing is this diagram. This diagram is actually more important because it gives you entire strategy in the form of flowchart. Okay, fine. Now let us come to the topic of our this chapter. Here, outlier detection and removal. What are outliers? We have already discussed them from box plots. That suppose this kind of box plot is there and this kind of table is there, actually right side is the box plot, and here some values are there. Maybe these are the values of employees, age of employee in one particular firm. Now 42, 48, 51, 54, 60, 35 are fine, but suppose these are managerial level employees, and the firm has a policy that they will not promote immature persons for managerial or higher level posts. So less than 35 is not allowed, and the 75 is obviously looking much higher. The reason is that before reaching age 75, the person would have retired. So that is also looking like outlier. But that all is dependent upon where rest of the data points are. And for rest of the data points, we can draw a box plot. We have already seen the box plot earlier. For any observation, this kind of, for any data, for any column or a single feature, this kind of box plot can be obtained. Now this is the minimum value, upper is the maximum value, and this is the median value. So whether a particular observation is higher or not, that is decided by median, or not actually by median also, but this is 25th percentile, and this is 50th percentile. Okay, and distance between them, 25th and 50th, that is the width of the box or height of this box. That is called that means this vertical height. That is called interquartile range. And normally what we have decided is that if from median it is at a distance of 1.5 times interquartile range, more than that, so then in that case we can treat as outlier. Now this is far above it, so we have called it as outlier. Similarly, if it is greater than 1.5 times interquartile range is this width, this height actually, so then this point is far below it. So at that time we can use that is outlier on the lower side. So this diagram says how to display the outlier. Okay, normally this kind of symbol difference is there. However, many of the libraries will not plot these different symbols. They will plot one and the same symbol. That means this kind of round only. But actually, a better library should plot for above the higher values. It should plot much higher value. It should plot plus sign, and for much lower value, it should plot minus sign. So here this 35, I said that it is much lower. Firm's policy is that a managerial employee cannot be less than 35 or 35. So this is much lower. So 0 or round and circle, that is. And this is beyond retirement age policy of the firm. So that is much higher age. So that is what is outlier. Now again, here also what we do is we create an artificial or synthetic data frame. Okay, and it has this column: product ID, sales price, date, and customer ID, and all that. And here later on I will append the new data, new records, and later on I will display the updated data frame. So that part I will put in next cell for better understanding. Okay, so first let us create the data frame only. So new record. Oh, okay, I think these are just new records. So earlier was better. Okay, so then new records are first created and then those records are added in my data frame using pandas library. Now many as such this is very common thing, but I would like to explain a few things. So let me go by that method only. Okay, here I will first print these new records. What are these new records? And then I will concat in my data frame. So these are three new records and these are going to be added in my original data frame only, because if you see here I have created a data frame, not this one, but for that null imputation I think yes that was this, perhaps handling missing value. So that data frame also has same product ID, sales, price, date, customer ID. Okay, so that also had the same columns and this kind of data was there, and thereafter we imputed null values by mean. Okay, then we introduced some other null values and that time imputed by median. Then we changed the data type also. So that thing, now this is now at least sales column, price column does not have any null values. Okay, in the sales column also it should be filled. Why it is not getting filled? Okay, now it is filled, right? Okay, so data type is changed to int 32. Fine, that's much what we had already done. So in short, what I'm saying is that this df is already existing. This is my df, okay, data frame. Now I am creating few new records. These are those new records, okay, and I am adding those new records at the bottom of the data frame. Okay, so how to add new records? Because new records also is in the form of data frame only. So that means I am doing kind of vertical stacking of one data frame over another data frame. So then, or one data frame, say new records is a data frame which I want to stack below the original data frame, that is df, that is this df. Now we know that vstack can be used, lstack can be used, or pd.concat can be used. This all discussion we have already done earlier. So I am displaying the updated data frame after concatenation, and you can see compared to original data frame, it had 19 records. Now there are 22 records. So 3 more records have been added. Now in these, the new records that have been added at the bottom, if you see them, you will find something unusual about those records. So what is that unusual thing? Then in the sales, this has pretty high values, 520, 550, 600. All other sales are maybe around 47 because these were none and we imputed. That is why maybe 63, 77. But in short, nowhere the sale exceeded double digit. And now suddenly all are less than 99, and they suddenly sales are 520. So whenever such an anomaly is seen, so at that time the person must be alarmed. Okay, so now you remove outlier. Now what is the way to remove? First detect outlier. So which column has outlier? As I said, sales column, base. So first detect them. What is the method to detect them? Detection is always done with respect to median, and also interquartile range. Okay, so then here they have done by standard deviation, so that is also fine. 1.5 times standard deviation. Sometimes we use 1.5 times IQR. Okay, so that is interquartile range, so that is okay. Each data requires a different strategy for treating the outlier, and that depends upon the nature of the data. So the median sales is df sales dot median. Let me put each in different cell for better understanding. Then there is standard deviation in sales. So for that, okay, so median cells, and let me print that median value for better understanding. So median is 47. So all these cells, their median value is 47. Okay, so now I have to find what is the standard deviation of this data set. So standard deviation in cells can be found by column name dot std function. Okay, these all functions are in NumPy, in pandas also many such functions are there, but mostly data manipulation is done by NumPy. That's why we not only import NumPy pandas earlier, but we also import NumPy with them. I earlier used a sentence that NumPy and panda make an excellent team. These two are almost always imported simultaneously. Okay, now then I got standard deviation. Now I have to decide what strategy I want to apply for standard deviation for finding outliers. Remember, I am still not removing outlier. I am just detecting. And here I am taking a definition that outliers are all points which are at more than 2 standard deviation. Again, that is just a subjective thing for some other In fact, more than 2 is written, but I think more than 1.5 only I have kept later on, because perhaps, okay, so more than 1.5 standard deviation, that points. So what you will do is find DF cells which are greater than median value, which is this value, plus 1.5 times standard deviation. Okay, this is standard deviation, or median value minus 1.5 times standard deviation. So that means from the median, find those values which are above or higher at a distance which is greater than 1.5 times the standard deviation, or which are less than, that is below 1.5 times standard deviation from median. So if I find them, and let us print those observations. So if I print, clearly the usual suspects were these three, because they are far above and they are all detected as outliers. Okay, I could have taken one of the observation as maybe negative also, just in case I want to detect that as a negative outlier. Okay, however, that is not very practical, because feels negative, so okay, better let us keep it. So these are only outliers on the positive side. All these values are far above the median. They are at a distance which is far greater than median plus 1.5 times standard deviation. Okay, so then you have found, but this is just finding outlier. Now what you have to do, you have to treat them. How to treat them? Again, there are different strategies. Okay, so one strategy is simple, that you do simply remove those. Remember, I have earlier warned several times that that strategy is not the only strategy, because it is a very simple use case. That is a different thing. But instead of removing, we can replace the value by some other value like median or some other value. Okay. So here what we are doing is that again I am detecting first outlier. This much is just detecting them outliers. Okay. So DF cells, but this time instead of greater than, I am just writing less than or equal to. So that means in my DF cells column, in the sales column of my data frame DF, I am keeping only those values which are less than or equal to median plus 1.5 times standard deviation, or I am in the sales column, I am keeping only those values which are greater than or equal to median minus 1.5 times. So that means I am choosing the values in a range. Suppose this line here, this white, this dark brown line, above it this faint line is there. So that line is suppose median plus 1.5 times the standard deviation, and similarly here suppose there is one line somewhere here above this circle, just above the circle, that is median minus 1.5 times standard deviation. So I am keeping only the values which are less than the upper boundary and greater than the lower boundary. Okay, so then those values will not contain any outliers. These will just find those observations which are not outliers. But if I have to save them, then we have earlier also seen that if you don't assign them to a new data frame, then in that case these values are only temporarily, this will execute, the command is correct, code is correct, but they will not be saved permanently. So you have to save the result in a new data frame, and then you can see. Those last three observations are not seen, 520 and something. These are 550 and 600. They are now not seen, but some explanation is given. So outliers are found those values which are more than 2 is wrong now, because I said that I changed it to 1.5. Okay, because but that keeps on changing, and that is discretion of the data scientist. So 1.5 times more than, which are at values more than 1.5 times standard deviation from the mean. So now you are understanding, in previous chapter we have introduced the concept of variance and standard deviation. So why they are important? Because whenever you are talking about distribution of data, how far away something from mean, above it or below it, then you cannot talk that 10 units away, 20 units away, 100 units away, because the column may have values 5,000, 6,000 something. So there is no sense in talking about 10, 20. Similarly, other column may have only values 0.01, 0.03, 0.02. So there is no sense in talking about in terms of 1,000, that 1,000 units away or over 1,000. So what is common between all data sets, whether the column's range is very large or whether the column's range is very small? Standard deviation will always be in the same unit as the unit of the column, and how far away a given observation is from the median, that is measured not by some absolute measure like 10 units or 20 units. It is measured how many standard deviations that observation is away. Okay, and we decide here that any observation which is median plus 1.5 standard deviation should be my last upper limit, and median minus 1.5 standard deviation should be my lower limit. So if it is greater than this, then simply mark them as outliers, and if it is less than this, median minus 1.5 standard deviation, then also mark them as outliers. But remember, this is usually this thing work only in normally distributed data. There are more advanced methods for detecting outliers, and we will see that. Outliers are excluded because otherwise your data will be skewed. Skewed means I have already shown in previous chapter that the data distribution does not come out to be a perfect bell curve, but it shifts on the right side or left side depending upon outliers are on the positive side or negative side. Now, above case is very simple, and outlier is simply just removed. We just remove those observations. But I already said that in one of the previous chapter that here it is sales, but suppose it is transaction amount of credit card, and the algorithm which you are building or the model which you are building is credit card fraud detection. So at that time, actually such high, extremely high value transactions compared to other observations, they are important. For example, these are the transactions in US dollar for one of my employees. He has done this many transactions in past 19 months. Every month he makes one or two purchases. Now we build a profile that this person mostly buys above $40 and less than $80. Suddenly, if a transaction comes like this, and if you just remove those transactions and then feed the data to the fraud detection algorithm, then your fraud detection algorithm will not detect anything because the most suspicious transaction which was here that you have detected. Similarly, if it is cancer lesion or tumor diameter, now these are normal ranges of tumor diameter in say micrometer, 47 to 77, but that type of tumors are usually supposed benign, but these three tumors are extremely large, so they have to be operated and removed. These are not interesting points. So in use cases where anomalies are of importance, then outliers are not removed. Okay, so we just stop and note down that these are outliers, but we don't remove them. That is one thing. Then this lower diagram shows the advanced method of outlier removal, and we will again not learn all of them, but we will learn a few of them. So let us see what are those advanced methods. Outlier detection can be done by supervised method or semi-supervised method or unsupervised method. At least supervised and unsupervised words I already introduced. Supervised method are those methods which have data with a response variable, and the response variable the value is given to you. For example, that case of predicting the sales due to various kind of marketing, our business problem, 4 types of marketing channels. Okay, now if here the business owner will give you a data of past 48 months, 4 years of the sales, that will not only include the 4 marketing expenses as the 4 columns, but it will also include the sales of those past 48 months. Okay, so the data would be somewhat like this. Somewhat like this kind of data is given to you for past 48 months. I have shown only top 5 rows. Now, TV marketing budget, social media marketing budget, radio marketing budget, and newspaper marketing budget, and these are the corresponding sales. These 4 are called features, and these sales is called response variable. So the business owner will give you 48 rows of for last 48 months of this kind of data. So that means for the past data, you know the value of response variable, and using that data, you have to build something which can predict the value of sales, using for some next 5 months when I change these values, that is I reshuffle the budgets for various 4 marketing channels. Okay, then that type of method, they are called supervised method. Why they are supervised? Because whole business is being done, prediction and everything, under the supervision of the response variable. But there are some other for example algorithms where this response variable does not exist at all, and you are just given that these are data points, that's all, and cluster them means what? That is that at the end of your model will plot a diagram something like this. So this kind of diagram would be printed. That means these data points are separated in 3 different groups, and each group having equal, somewhat similar characteristics, and their characteristics are completely different from other colored groups. Okay, 3 is not required. It can be 5 cluster, it can be 10 cluster, it can be only 2 cluster, like that. But for that, there is no response variable required. You just have to find some similarity between various observations, and those which are similar to each other are put in one cluster. Those which are different from each other, they are put in other cluster. For example, similar plots one must have seen during the COVID or Corona, that green clusters are those regions of the country where corona is already in control. Red are those regions where maximum numbers of cases are being recorded. Yellow are those where the cases are on the wane, they are decreasing but not yet fully controlled. Okay, so that kind of clusters were seen during COVID. Everybody must have seen that kind of diagram. Okay, so that is also an application of data science. Practically everywhere data science is used. So now this type of method where response variable itself is not there, you are not predicting anything, you are just collecting your given data points into some kind of groups or clusters which based on similarity and dissimilarity. These are called unsupervised method, and for them there is no response variable is provided. And semi-supervised is somewhat in between. Okay, here semi-supervised is written in clustering, but actually clustering should be unsupervised method. Okay, fine. Now here k-means is written, that k-means is itself clustering. But semi-supervised means what? It is possible that there may be 1,000 such rows among which the response variable is given for maybe 700 rows, but it is not given for maybe 300 rows. So like that. So it is not fully supervised and not fully unsupervised also, but semi-supervised. Now outliers can be detected by all three types of methods. So these are some supervised methods: Z-score, interquartile range, K nearest neighbor, KNN algorithm, then decision tree, random forest, support vector machine. Here I have written that this detailed discussion is beyond the scope of this course, but that is because I actually wanted this to be basic data science course. Otherwise, now we will learn each and every of these algorithms. Of course, we'll use it for a different purpose, not for outlier detection, but it can be used for outlier detection. So we'll learn each and every of this. K-means also will learn, DB scan also will learn, and isolation forest also. Auto encoder perhaps I think we have not learned, or perhaps it is not there in your portion of this course. Okay. These are some outlier detection method, more advanced method than simply that 1.5 times standard deviation more than median, or 1.5 times standard deviation less than median. This is also similar one diagram. Basic categories are still same: supervised, semi-supervised, unsupervised. But then the strategies are different. If it is a simple data set, then use parametric method. Now don't bother what are parametric method. We are going to cover this many parametric method. Then not if either parametric or non-parametric or semi-parametric. If the data set is complex data set, then see if it is high dimensional means there are several rows. If it is a sequence data set, for example, time series like data set where the dates are in sequence, for example, the price of a particular stock for last 1 month and every day's price is there. So the date will exactly at the interval of 1 day, that is 24 hours. Spatio-temporal space-time data set, spatial data set, for example, it is the data set of land record of a country, or maybe which part of country is growing wheat, which part is growing other crops, maybe rice, and so on. Mixed attribute data set, streaming data set. Streaming data set most common is the Netflix, and examples are Netflix or maybe the Prime Video or that kind of thing. And depending upon that, you will use different methods. Sometimes use depth-based method, graph-based method, neural network-based method, density-based method. So some of these are different. For example, this DB scan is density-based method. This support parametric, most of these which are written above this on the left side particularly, they are parametric method. You have to specify some parameters. Tree-based method. For example, this decision tree and random forest, they are tree-based method. So we will see many of these methods in our course as the course progresses. But as I said, we will see those methods as an independent technique. Now, we may or may not cover its use for outlier detection. That is a different thing. But once you learn the technique, then you can use it for any other purpose. Next lecture, we will take this thing. Third step or third thing which you need to do in data wrangling or data manipulation. That is detecting duplicate rows and then deduplicating. That is relatively very easy compared to previous two.